frequency distribution represents how often each value of a variable occurs in a given set of data, providing a comprehensive picture of what values of that variable occur in the data set and how often. The type of graph to use for a frequency distribution depends on the variable's level of measurement. Typically, frequency distributions for nominal and ordinal level variables are plotted in a bar graph. This example shows the preferences in a sample of students for each of 4 study methods. The values of the variable of interest span the x-axis, and frequency of occurrence is indicated on the y-axis. Typically, the y-axis of a bar graph begins with 0 and continues to a value just beyond the highest frequency in the distribution. Also, because the variable is on a nominal scale, the order of the categories on the x-axis is arbitrary. The order could be alphabetical or random, or the categories might be ordered by increasing or decreasing frequency of occurrence. With ordinal level variables, the order of the values follows their inherent rank order, but because the values are not necessarily spaced evenly on the underlying dimension, the width and spacing of the bars are again arbitrary. In this example, the y-axis shows the percentage of responses instead of the raw frequencies, so that frequency of occurrence is displayed relative to the total number of observations. You may see the y-axis labeled relative frequency instead of percentage. Again, because of the arbitrary order and distribution of the values on the x-axis of a bar graph, the particular shape of the frequency distribution in a bar graph is not meaningful. In contrast, for interval or ratio level variables, the shape of the distribution is meaningful because the units on the x-axis are evenly spaced. Here, we see a mostly flat distribution of frequency for years of school completed, except at the points in time that correspond to the most frequent years in which people complete high school, junior college, or college. This type of graph is called a histogram. In this example, the frequencies of the values of a discrete variable are plotted, so as with a bar graph, each bar represents one value of the variable. However, the order and spacing of the bars are no longer arbitrary. This is because the x-axis of a histogram represents an interval, or ratio level measurement of the number of years. Now, let's compare these graphs. Note any differences in structure that you find. Do you see how bar graphs and histograms are structured differently? Notice that the bars are spaced at fixed distances in the bar graph, because the arrangement of values on the x-axis is arbitrary, whereas in the histogram, the axis reflects at least an interval level measurement. If there are spaces between bars in a histogram, then it means no observations occurred for those values of the variable. Another difference between bar graphs and histograms is that if the variable on the x-axis is continuous, or if there's a large number of discrete values, the bars in the histogram might represent ranges of values instead of a single value, as shown in this figure where the first bar represents values ranging from 17.5 to 22.5 years of age, and so on. Each bar in a histogram may be referred to as a bin. In this histogram, each bar represents a bin with a 5-year range.